Hello students, I welcome you in today's session of physics. As you all know, we are discussing a topic which is your gravitation, and in this topic we are talking about the planets and satellites. So as you all know, in our two previous lectures we had covered Kepler's law of planetary motion. As you can see here, this thing we have to already covered out. Clear? We also cover these are the Kepler's third law, Kepler's second law. I hope you understand it very well. After that, we cover the Newton's law of gravitation. This is the topic we have already covered out. So today's now we will talk about the gravitation constant, which is your capital G. Clear? So Newton's law of gravitation is, as you all know, in our previous lectures we have discussed about this force which attract a body towards the center. F is equals to G m1 m2 by r square. I hope it is clear for you. This is the force by which an earth attract a body towards its center. Clear? So in place of mass, if we take mass is unity, both the masses, that is m1 is equals to m2 equals to 1, and the radius between the two bodies is equals to 1, then what we will get? We get here G is equals to F, means the gravity or gravitation is equals to the force of attraction between the two bodies. So we can say that the gravitational constant G is numerically equal to the force with which two particles each of mass how much unity and placed at a distance apart, unit distance apart from each other. You can see here. So unit of G from the above observations, we can find out the value of G. G is equals to how much? Fr square divided by mass, that is m1 m2. Clear? This is the value of G. The SI unit of force, distance r and mass are Newton, meter and kilograms respectively. Therefore, the SI unit of G is how much? Newton meter square per kg square, or you can also write it meter cube per kg per second square. Clear? Similarly, you can also write this unit for the CGS system. If we talk about the gravitation constant in CGS, so you can write in place of Newton meter, you can write centimeter square per gram or centimeter cube per gram per second. It is also known as dyne. Smallness of G, we are skipping this topic. Universality of G. Here you can see this is, we have to discuss here universality of G. In the law of gravitation, the value of constant of proportionality, which is your G, this is your proportionality constant G, supposed to be the same for all pair of body at all places, at all times, at all distances of separation, and also independent of the presence of other bodies or the properties of intervening medium. You know what are the intervening medium, whether it is water or air or any other medium you can consider here. The correctness of this assumption depends on the correctness of the deduction using it for the motion of the planets in the solar system and our bodies falling near the surface of the earth. There is so far no evidences against this assumption, hence G is regarded as a universal gravitation constant. I hope you understand it. What the G means? G is a universal gravitation constant. It is not a, you don't consider it like small g, because small g is a acceleration due to gravity. There is a relation between both of them, capital G and small g. We will talk about later. So we will now today consider our next topic, which is your gravity. Clear? So what is gravity? In Newton's law of gravitation, the gravitation is the force of attraction acting between any two bodies. Clear? If one of the bodies is earth, then the gravitation is called gravity. What does it mean? In Newton's law of gravitation, the gravitation is the force, means gravity is a force of attraction which exists between the two bodies, in which if you suppose the one body is earth, so we can consider here the gravitation is called gravity. So we can define it like that. Gravity is the force by which earth attract, here you can see this is the definition we are talking about. Gravity is the force by which earth attract a body towards its center. Clear? Clearly, gravity is a special case of gravitation. It is due to the gravity that bodies thrown freely ultimately falls on the surface of the earth. Means if you thrown a body upward direction, then due to the mass of the body and the acceleration due to gravity, its weight is acting vertically downward. Clear? Now we will move to acceleration due to gravity. Here you can see this is the acceleration due to gravity. So when a body is dropped down freely from a height, freely means the body is going in the downward direction only due to the force of gravitation. You can say also this is a freely fall body. Fine. So it begins to fall toward the earth under gravity, and its velocity of fall continuously increases. So if a body is coming under the force of gravity, its velocity is increasing time to time. The acceleration developed in its motion is known as acceleration due to gravity. I hope you understand what is acceleration. Here we are talking about the acceleration due to gravity, but in the equation of motions we have considered there acceleration, which is a linear acceleration. So acceleration is nothing but the change in velocity with respect to time is known as acceleration. Fine. Now here we are considering the acceleration due to the gravity, so that's why it is called as acceleration due to gravity, and it is denoted by small g. Fine. Thus the acceleration due to gravity, how can we define it? The acceleration due to gravity is the rate of increase of velocity of a body falling freely towards the earth. Clear? At which, the rate at which a body falling towards the earth is known as acceleration due to gravity. This is the definition, you have to consider it. It is denoted by small g. It does not depend upon the shape, size, mass, etc. of the body. Clear? If suppose if m be the mass of the body, then the force of gravity acting on it is mg. As I already told you that the gravity, the weight, what is the weight? The acceleration due to gravity and mass of the body. The multiple of mass and gravity is known as your weight, which is acting vertically downward. Therefore, the acceleration due to gravity is, here you can see that the acceleration due to gravity is equal in magnitude to the force exerted by the earth on a body of unit mass. I hope it is clear. The unit of acceleration due to gravity. Now we have to write down the unit of acceleration due to gravity. So unit is meter per second square. It is same as the acceleration which you study in the equation of motions, or you can also write it Newton per kg. The universal constant, which is your capital G, is different from G. This is different from small g. The constant G, which is your universal gravitation constant, has the dimension formula m inverse L cube t minus 2 and is a scalar. Clear? Vector G has the dimension Lt minus 2. It is a vector and is neither universal nor constant. Its value of small g vary from place to place. Expression of acceleration due to gravity is small g in terms of gravitation constant. Now this is the important topic which is come in your examination, how the small g is related to the capital G. Clear? Suppose that the mass of the earth is me. What is the mass of the earth? We suppose the mass of the earth is how much? Me, and its the radius of the earth is re. So assuming earth to be a spherical. Clear? Here we are considering the earth is a spherical, but it is not possible because earth is an elliptical shape, as you all know. So its entire mass me may be supposed to be concentrated at its center. As we consider here the mass of the earth is me, and we are supposing here that the mass of the earth is to be concentrated at its center. Let us suppose a body of mass is small m be situated at the surface of the earth. Clear? Or you can also consider it at a small distance of the body from the center of the earth may be taken as re. So how much distance we have to consider here? Re. So according to the law of gravitation, the force of attraction acting on the body due to the earth is how much? F is equals to G MEM upon RE square. This is the force we have already discussed in our previous topics. The force of attraction due to the center of the earth. Clear? On other body. So the acceleration due to gravity, as you all know, is small g in the body arises due to the force F. Hence, Newton's second law. What is the Newton's second law? F is equals to ma, means force is directly proportional to the mass into acceleration. Now here the acceleration is gravitational acceleration, so F is equals to how much? Mg. So this force is also an attractive one, and the value of force here is mg. So from equation 1 and from equation 2 we comparing the both the forces. So what we will get, we get here mg is equals to how much? This is your mg is equals to g MEM by re square. Clear? So here you can see that me and me is cancel out, sorry, m and m is cancel out, small m, fine. So you will get the value of a small g in terms of capital G equals to how much? G is equals to gme by re square. This is the relation between the acceleration due to gravity and the gravitational constant. I hope you understand it very well. Now this expression is free from m. As you can see here, the mass of the other body is not given here. So this equation is totally independent of mass. This means that the value of g does not depend upon the mass of the body. Hence, if two bodies of different masses be allowed to fall freely, clear, they will have the same acceleration. And if they are allowed to fall from the same height, they will reach the earth simultaneously in the presence of air. Clear? However, the buoyancy effect, buoyancy force, I hope you know very well what is buoyancy. Buoyancy is nothing but a force which is acting in the upward direction, or you can say it like a thrust. And the viscous drag, viscous force is also, there is a relative motion of the layer of air or any material or medium which causes different acceleration in the body. In case the heavier body will reach the earth earlier, means if there is a vacuum, not in the presence of air, in that case the body which is heavier reach the earth earlier as compared to the lighter body. I hope you know the concept very well what I am trying to convey you. Now we will move to computation of mass and density of earth. How you can compute the mass and density of earth? This we have to study here. We may compute the mass and density of earth from Newton's law of gravitation. From this relation, as you all know, we have already proved here, g is equals to how much? gme by re square. So the mass of the earth is me is given by me is equals to g re square by capital G. This is the relation of mass of earth, and these all things are coming from the same formula which we have already proved here. From this formula, which is your equation number 3, you can see here all the formulas we have proved from this formula. So here you can write me is equals to how much? g re square by capital G. Now substitute the value. As you all know, g is a small g, acceleration due to gravity, its value is 9.8 meter per second square. Here it is written that re, radius of the earth, is 6.37 into 10 to the power 6 meter. Clear? Capital G's value is also it is a universal constant, so 6.67 into 10 to the power minus 11 meter cube per kg per second square. So after putting all the values in our equation number 1, as here you can see in this equation, we will find out the mass of the earth is equals to how much? 6 into 10 to the power 24 kg approximately. Clear? Similarly, the average density, now what is the relation between the density and mass? Mass is equals to density upon volume, as you all know, or you can density is equals to mass upon volume. So from that formula we can write down like mass is equals to volume into density here. Clear? So the average density of the earth may also be calculated. Earth is a sphere of radius re, and rho is the density. Be its average density, then its mass is equals to volume into density, and volume is which is the volume of a sphere. Clear? The volume of a sphere is how much? 4 upon 3 pi r cube. Now what is re? Here r is the radius of the earth, so we considered here re cube, and rho is the density. So substituting this value of me, now we put this value of me into which equation? Equation number 1, which is our this equation. Here we can put the value of me from this. Clear? So after putting the value of mass of earth 4 upon 3 pi r cube, you can see here we will get 4 upon 3 pi r e cube rho is equals to g r e square by g. Clear? So after solving all the cases here, you can see that re square re cube, here it is a cube and here it is a square, this cancel out. Fine, you will get density is equals to how much? 3g by 4 pi re into g. Now substitute all the values from above relations, value of g, re and g. You will get density 5.5 into 10 to the power 3 kg per kg meter cube. I hope you understand it. But it is clear for you. So our next topic is variation in the value of acceleration due to gravity. This is topic we will cover in our lecture number 4. That's all for the today's class. Thank you, class.